Good afternoon. I have just uploaded my version of Chapter 5's risk assessment, my own personal assessment. I hope that you approach that Chapter 5 now that I have it as a doable assignment. I hope you'll take that Chapter 5 and use it to see the things that you might need as far as putting controls in place for risk. While I was doing that, I called my ISP and said, I've been advised that maybe I need a firewall. I know you guys provide a firewall, but I just want to make sure that I don't need another one because I do have an added virus protection, even though the Windows operating system comes with their own virus protection. And the lady told me no, that that they have the firewalls on their end that's covering our end, and then if I have virus protection, I should not need an additional firewall. So that was one of the questions I had for myself. So Chapter 5 is risk and how you can put things in place to control those threats. And hopefully you do that ahead of time so that when the threat actually happens, then you won't lose data and your equipment. Now, Chapter 6 is security technology, firewalls, and the virtual LANs and all of those things. This one says if you think technology can solve your security problems, then you don't understand the problems and you don't understand the technology. And you see that all the time. Well, why hasn't hackers hacked that particular place? It's honestly just because they hadn't got around to it. I know that sounds horrible. We're trying to learn cybersecurity, but we got to stay one step ahead. Discuss the role of access control in computer-based information systems, and we know that there's a balance between access and security. The most widely used authentication factors, and that is for entry, to authenticate the person that's trying to get in. Describe firewall technology. Identify approaches to control remote and dial-up access for authentication and authorizing users. Content filtering technology, and then virtual private networks and the technology that enables them. And that's what runs our world, right, is that most companies have a public network, just like we do, sneed.edu, and then we have a private network to do our business on. Technical controls are essential, right? They have to be properly implemented. They have to be monitored. We were just talking in my one of my classes today that most hackers get out there and run around for a long time before the company ever detects that they're there. So the monitoring is important, confidentiality, integrity. So access control. What are you going to use to admit users into a trusted area? And usually that, not all the time, but that trusted area is online. One of the things that I caught my eye, and I do try, and I don't every day, but I do try to look at news articles for the day. And the one that caught my eye this morning, and I'm pretty sure I put it in our class, there. Why the FBI needs to double dip Huntsville, the city of Huntsville. That's what that was on the news this morning, and it talks about not only do they have online data and online important classified material, but this also talks about the physical and what all of those companies do with the arsenal and all that kind of stuff. So it's a pretty good article. I hope you take the time to look at that, especially if you want to look there. So how do you limit user access, or how do you determine how to let a user in? The mandatory access controls. Now there's MACs. That's the acronym MACs, but there are also a MAC address that comes with your network interface card, so don't let the acronyms get you. Use data classification schemes on those. The discretionary access control allow users to control and possibly provide access to resources. Strictly enforce the MACs that are managed in a central authority. We were looking in the database class right now that even though you love those employees and you trust them, there should also be checks and balances with your with the people who run the database, the DBAs, to make sure that they don't manually change something, to cover their tracks or whatever. People are people. We all screw up. It's just a fact. So we have a mandatory that is controlled by the organization. The discretionary, I consider my password. They may tell me how long it has to be, but they usually don't tell you what its makeup is. So we have some discretion there. And those resources do change. I mean, it might be a database, it might be employee records, it could be fingerprints that we just saw this last week, that when they hacked into the government employees website, not only did they take Social Security numbers, they also took fingerprints, and that's really for entry, right? A lot of those places on the arsenal, you can't get in just by typing in a user ID and password. They use some kind of biometric that's covered in this chapter. So, sure, if they had those fingerprints, they might could get into buildings they shouldn't have got into. The identifiers is something we name usually, and in programming I'm used to that being a variable name. The connotation elements that add those things together, it can be an ampersand, it can be a plus sign, it can be different things that add more than one thing together. The department codes, random numbers, special characters that make those things unique. And it's talking about, the things that we use to put that added security on there. Some organizations generate random numbers. And if you look online, there are password generators that, it just generates a password. What I've come to do lately with passwords, and I started to put this in my response to Chapter 5, and I had already turned it in, but I use numbers. So, now, this isn't a real one, but this will show you. Let's see. I use words that I can remember, and instead of that S, I would use a 5. Okay. Again, I might use a 5, or I might use a capital there. So, and then I do put just a string, sometimes of symbols. Sometimes I do something like this to put the symbols, however you do it. But anyway, there are password generators too. The purpose of validating the identity of somebody, a password, a passphrase, and we do a sentence, what's your first dog's name, what city was your mother born in, all that kind of stuff. So it's a virtual password. Authentication, a dumb card or a smart card that verifies you are who you say you are. The synchronous and asynchronous tokens. Synchronous means it happens at the same time. Asynchronous means it doesn't. So all of those. A supplement, individual characteristics, strong authentication. The authorization is to match that, and it does it really fast. You see that when you put your credit card in a gas station. It takes less than a minute for them to go out there and grab that database and see that you're in it, right? But they do. It happens really fast. Authorization for each authenticated user. It's handled in one of 3 ways. For members of a group, and authorization across multiple systems. And you see that sometimes, not so much at SNEED, but you do see that. I think I've put in a video before that it got real popular there for a while to have one sign-in login. Well, when you do that, they've got access to every single thing. And then authorization tickets. Accountability. That's what we were talking about in the database class this morning. It says you have these user accounts that can control the whole database. And those user accounts need to have safeguards against each other. It checks and balances kind of system, and that's what that's talking about, the accountability, the auditability of that thing. And it shows us in our database classes how to audit even those very top users, the DBAs and the system DBAs. System logs and database journals, just exactly what I was saying. You'll find that not just in databases, but you'll find in other software that it keeps logs of everything that's done. A database, one of those, not Access, it's a small database, but Oracle or SQL Server. I hope some of you listening to this do plan to make database your track, database management, because there's good jobs out there in that, if that seems appetizing to you, I guess. But it works with logs. Everything that every user does to that database is committed to a log. The time that it was done, what their name is, all of that stuff. They have many uses. It's to maintain the database and to keep it running, but it's also to give you that audit trail. Biometrics, and we know that, right? I don't know. That's not true. That statement, I didn't make this PowerPoint. The book made this PowerPoint. There are other things besides fingerprints, your eyes, that are truly unique. Now, I've just seen it in so many different places. I'm going to do a Google, and I don't want to run past my hour. If I'm going to, I will record 2 for this chapter. I may stop. And your faces. Have you ever put a picture up on Facebook? And I just did that. My son and my little grandson was in the foreground of that picture, and my son-in-law happened to be standing behind them. Well, I uploaded that picture, and it automatically tagged my son-in-law based on his face recognition. It really is your bone structure. It is not limited to fingerprints or veins or face licorice, DNA, palm print, your hand, your eyes, of course, your voice. So when I read that, that's not true. It's just, maybe those are the best ones that are truly unique, but that's just not true. I don't consider that intrusive, having to put my hand there or my fingerprint there. Some people might. So there you go, looking at your face. That's really pointing out your eyes, but it does mention your voice. Of course, we knew that our signature was, and it is the actual size of your face. It's the bone structure, the size of your hand. And then how universal they are, how unique. And I think that's what that was showing us. Do you see that your odor and your scent is unique to you? I know. And it's high in uniqueness. So it says the face is low because you can favor other people, right? The voice is low. They're actually perfecting voice software so much better now. Signatures can be copied. Those kinds of things is what it's talking about. Trusted computing base, that is the architect models. They're in the book for this part. Shows you how those models are used for authentication, used to enforce security policies. How do you store it and how do you time it? I wanted to hold on just a second and I'll add to this. Sorry, I had thought I paused it for a minute. So these are all models that are set up to look at what you're trying to evaluate for security, and then how you're going to go about it, and then if it's a good plan or not. So that's what the first part of this chapter is doing. And then firewalls. Prevent specific types of information from moving between an untrusted network, the internet, and a trusted network. And I've already shown you the difference between a www site, meaning that it's public to the World Wide Web, or an HTTPS site that is protected just by looking at the URLs. So here at SNEED we have an internet that is public. We have an intranet that's private. So, and most companies are the same way, right? If they're your water bill or your electric or your garbage or whatever, they'll have a website so people can they can attract new customers and help existing customers. And then once you're a customer, they provide you a way to go online and do your business online. And that's what it is. So a firewall is a restriction kind of technology. It can be software, it can be hardware. This book tells us there's actually 5 different kinds of firewalls. And I'm getting ahead of the PowerPoint. There's a packet filtering, an application gateway, a circuit gateway, the MAC layer firewalls, and then there's hybrids of those. So there's different types of firewalls. You can decide if you're going to do like me and trust your ISP with your firewall. So it may separate the computer system, may be a particular software, separate the network from other devices, and those are our 5. I would hope, and it may not be true, there are so many classes here at SNEED that you need other classes before you take that class. They're called prerequisites, but we don't do very many unless it's a true prerequisite. Like you have to take beginning Visual Basic before you can take advanced Visual Basic. But in the Intro to Networking class, and that's offered this fall, CIS 161, it talks about the header section of a message and what's included in there. And so there is a head of every message, and sometimes messages just, this is my layman's way to explain it. And you guys that are network guys, if you want to get on there and do a better job than me, you can, because I don't consider myself a network guy. I've always been an applications person, but I do know this much, and I have taught the Intro to Networking class. It's been several years, but I have. And I know that I need a refresher on that because it's changed. But anyway, messages that flow across the internet, whether it's email messages or whether it's a file like a Word document or whatever those are that's flowing as an attachment, that may be broken down to several packets. One message could be several packets, but every one of them has a header section. And there's lots of information. I'm going to save that for your 161 class, but there's lots of information in that header section. So there's packet filtering firewalls there that examine the header section, looking at the sending IP address and matching it to whether it's blocked or not. So do you see, it's often based on the combination of the IP source and the destination address, whether it's inbound or outbound, the TCP protocol and the U2B source and destination port requests. Now this is why I have in Blackboard a list of those of those ports, and I have done a little bit of research on this because I want to make sure I was updated and current on it. Let's see, biometrics. That's another topic, but I have it in one of these. That one, I hate it when it's got a script going. Okay, these are the port numbers, and there's some that are official. A particular software or a particular technology has that one. Some of them have been made official. Some of them are still not official. Do you see that there are that many that, and it's really not consecutive, you see, but that are already are took up, and then there's this number to 65,000 are dynamic. They're not registered with the IANA. These are ports that network administrators can use for their own purposes, just for temporary things. But if you look at this list, you'll see very common software, and it uses that particular port to come into your machine. So this protocol, and sometimes you see on there they're the same and sometimes they are not. So simple firewall models enforce the rules to prevent packets with those addresses from passing through their through the firewall. So if it's a known, I was trying to think of a really good example, but it's a filter. The firewall is set up to filter those out. Excuse me. I hate to cough when I'm doing a video. Oh, here's your header. Oh, good. That shows you that I slept since I've looked at this PowerPoint. The header version, the type of service, the identification, and some flags. There's the time to live, that's its life, shelf life, the protocol. The checksum is an error checking. There's the source IP address, the destination IP address. So when I tell people that everything you do online is trackable, this is why. It sends your IP address with it every time. And you can see in your control panel what your IP address is. The sequence number to put them back together, to put all of the parts of the packet back together. So, an untrusted network goes through the packet filtering router, and then before it actually gets into the trusted network. The source address is showing you how it can be set up, the rules from this source address going to that destination. Anybody will accept it. They will deny or allow. 3 subsets. Static filtering require that the rules be developed and installed within the firewall itself. Dynamic allows the firewall to react to certain events and update and create rules to do with it. It kind of makes its own decision. Stateful inspections keeps track of each network connection, internal and external, using a table that has already been set up. Internally, of course, every computer would have its own static IP address. When we connect to the internet, we actually don't. We use a dynamic list of IP addresses. But and you can see that in your control panel. You can see your IP address. The entries, there's the source where it's going to, the port, the source port it came from, the destination port, how long it has in its life still, and then what's the protocol. The application layer firewall, and that's called a gateway sometimes in this chapter, is installed on a dedicated computer, usually the proxy server, and maybe there's a zillion proxy servers. It's usually placed in an unsecure area, it is exposed to greater risks. Additional filtering routers are used. So that's the application. Let's see. And it does give us these pictures in our book as well. In networking, there are two models, the TCP model and the OSI model. And that's not always been true. When I first started doing computers, there was other models. But basically right now, there's two models. And this shows you, and I really like the way this looks. There is the OSI, and this is the TCP/IP. And they do the same thing. It's just that they do it in different places in setting up a network. The subnet are those, the physical, like the jacks for the connections and all that. The network interface cards. There's your network layer or your internet layer, same. The transport layer is the same. And see, there's your UDP and the TCP ports. And we just saw that list. So do you see that there's a MAC firewall here where the network interface card is on your machine? There's a packet filtering here, SPI firewall here, and then an application firewall here. So these firewalls have put at multiple levels and generally speaking are pretty self-reliable. So the application layer on the TCP model are these three layers on the OSI model. If you're setting up a network besides Cisco, maybe, I'm not going to say anymore because I don't want to say anything that's not true. You guys know more than I do. So the hybrid firewalls contain elements from the others. You may have separate devices on each in different levels of the model. So you can make improvements at one level without changing or messing up the others. And I think that's what's important about that. The firewall architectures configured different ways. The best configuration, the objectives of the network, the organization's ability to put them into place, and the budget. So you do have to look, like I was saying, maybe the government has better or more stringent security needs than SNEED does, although SNEED considers its data and everything else important too, but still, the government would have more money than us as well. 4 common implements of the firewall: packet filtering, dual home. Those are called Bastion host, screened host firewalls, and screened subnet firewalls, and we just saw that right there. There is between internet and intranet. The routers reject that the organization doesn't allow. There's a lack of auditing and strong authentications used with firewalls. This is called a sacrificial host. It tries to be kind of like a decoy. It combines 2 network cards, one connected to the external, one to the internal. It makes creates another barrier from external. So we have multiple firewalls at multiple levels. I didn't know how to do this part. These are classifications of IP addresses, whether it's a top-level domain, and then these are the new IP6. We were using IP4, which we ran out of IP addresses, and now we use version 6, so there would be so many more sets of those addresses that we can use. So the 4 had 4 oscillates of numbers ranging from 0 to 255. That, let's see, I'll find it. There is a breakdown that shows you exactly how that works. Hold on just a second. Okay, I just took the time to close a few things. I wanted to show you that this is my local area connection and this is my student's wireless. I hesitate to show you how you can look at that IP address, but it's under properties. Windows wants to help me, and our IT department makes sure I don't want to change anything. But to show you that you can see what your IP address is at home. If your ISP gives you that number, the first part, of the number is the top level domain, whether it, actually you can look and see, but each one of those are giving you a different piece of information. Ours is, say 172 here at Sneed, and then on down to the final machine at the end. So the IP address itself tells you a lot, and I'm just breezing right over that because you will learn that in your Intro to Networking class. I hate web pages that actually have a script running on them because that always crashes websites. So the domain, looking at the external filter, the proxy host, and all of the levels of security. That is a dual home Boston host firewall. Screened packing filtering with separate dedicated, such as the proxy server, and we've just seen that. The router to pre-screen packets, all right, to minimize the load, just not let them in if they shouldn't be. External attack to compromise 2 separate systems connectors. So what we actually need to protect. The screened one, this begins on 329 in your book, where it's blocking certain data packets, filtering those through, and then you have the proxy with the other firewalls and the different as you go through. DMZ, the dominant says that is the dominant architecture today. 2 or more hosts behind the, packet filtering routers. Connections from outside and untrusted are routed through the external filter. Then to separate the segment known as DMZ. I was looking, let's see, that doesn't actually tell us, so I was trying to look back in the book as I was going through this to see what DMZ actually stands for. It's a dedicated port on the firewall device linking a proxy host or so it can be connected to the screen subnet. I still don't see it. But anyway, I'm going to go on as to not make this really longer than it needs to be. Okay, so connections from outside are filtered. Connections are routed to separate network, and then the trusted ones are allowed from the DMZ host. It can be a dedicated port on the firewall linking the proxy host, or it can be connected to a screen subnet, and that's what that picture was showing, through the untrusted network and placed in the DMZ. I'm going to pause just one more time, and I'll try not to do that anymore. Sorry, I did read the chapter carefully, but I had to just look that up again. The demilitarized zone. It is the parameter network or the physical or logical subnetwork that that you're trying to protect. Okay. So whether when you're looking from outside an untrusted network, going through a router to separate the untrusted from the trusted. And that shows you a little bit of how it looks. If you've got a controlled access and then a proxy access, you're dividing those things up so that you can put more safeguards on one part than you do the other. And I should have just come on a couple of slides and I would have saw that, but I just couldn't find it right off the top in the book, even though I've highlighted my book as I went through it looking. The web server, the proxy server, the email server, there could be database servers, there could be file servers, application servers, lots of different kinds of servers in an organization, showing you the internal IP address and then the firewall admin's IP address, all of the things that we try to do to keep that secure. That 10-10-10 is called a proxy. The screened subnet protects the demilitarized zone from the outside threats, protects internal networks from limiting how many external connections can gain access to the internal. And then another part of that is the extranets, and we talk about that now. I put it in PowerPoints before. We've got the internet everybody can use, intranet that we're trying to secure, and then that extranet is your company, but it's also other companies so that you can share information between those companies. So that another thing that is under. The SOC servers are on 331 in the book for how is the protocol for handling it via proxy server. The proprietary circuit level proxy server has a special SOC client-side agents on the workstation. They can require support beyond those of traditional firewalls. That is actually, the SOX server is a firewall that um, is used in the secure socket implementation of the TCP um, architecture. You really need a networking guide for this chapter. The right firewall. The factors, what's the balance between protection and cost? We've already seen that more than once. We saw it in the chapter 5 and the rest. What features are included in the base price and what are not? What are going to be additional costs? Ease of setup and configuration. How hard it is to maintain. The accessibility to technicians to configure it. Can it adapt to the organization's growth? And then, of course, the second most important issue is cost. So the first issue is to weigh those protection against the cost. To set up a initial configuration, draw you a picture of what you have. What firewall device has its own configuration rules, and then the policy is usually complex. Yeah. The firewall policy is an art and a science because there's, you know what I think of when I see that, and I see it a lot in computers. There's no one way to do it. It's a science because there are proven methods, but it's an art because it can be set up in multiple ways, and it depends on the people setting it up. How artistic, it's not really talking about art, but it's talking about all of the things that go into making a good decision for that. The security rules, there we go. Is that true? If it's a trade-off between ease and performance, then security sometimes gets put on a back burner. All traffic from the trusted network is allowed out. Firewalls never directly accessed from a public network. I told my ISP when I called her a while ago, I said, I just looked all over your site to see if I could see anything that you told us about what kind of firewalls you use and what kind of setup. She said, of course that wouldn't be there. That'd make us less secure. And I said, I know. The emails are allowed to pass through the firewall. The control data are denied. Telnet should be blocked. I wonder how much Telnet is used anymore. I used it years and years ago just with data entry. Telnetting to our home office what we needed, our list of what we needed. But I just wonder. It was a strange looking machine then. I wonder if it's changed. I haven't used it since. If web services are outside the firewall, the traffic blocked from reaching the internal networks. All data authentication that cannot be authenticated should be denied. The firewall rules, right? Examine the data packets. Have a predetermined rule for putting that comparison in place. I have a set of guidelines. The firewall rules or the logic behind it. Use packet header information for that filtering process. So the port number, the port 7 is an echo. 20 is file transfer protocol. And there's lots of companies that still use that. The Telnet, the simple email domain name systems, HTTP, the other email configurations, well-known port numbers. There's lots of them now. Lots of changes. The rule, the IP address, whatever source it's coming from, the destination, the port that it's coming into, and then the action, looking at how you might set that up. It's really hard sometimes. Virus code, for example, can be can be tacked on to code in a Word document, for example. It's not always a standalone document that comes into. And those are you can't filter those. I mean, the port number that's for Microsoft Word is what it is. And they're just always allowed because that's the kind of traffic that you're having a lot of times in business. So the rule set. Software filter is not a firewall. It allows administrators to restrict from within a network a set of scripts restricting the address from certain network protocols. Do you know that's one of the things that differentiates the good side of the internet and the dark side? The dark side has that you have to have a special web browser to go there. And so that keeps that traffic, dark side traffic, out of off the firewalls a lot, but not always. It is special software though for those sites. The restriction of internal and external, from non-business website to deny incoming spam, protect the remote locations, and I am just going to go fast on this part. Unsecured dial-up connections. I'm not sure. I'm sure there still are those, but not as many. The attackers can use a device called War Dialer to locate the connection points. It's an automatic phone dialing thing that tries to pick up the connection points. Some technologies have improved authentication, remote. Most of those are remote or just a dumb terminal access. The remote people, and we see that if you use NetLab in your classes, and if you're taking any database class or the beginning networking classes, we're using NetLab. That's a virtual machine that is remote. Actually, it can come from any computer, showing you the network ASIC server and the radius server approves rejects that are requested. The NAS then provides access to the authorized person. This one is used with a Windows operating system. That access, it's a secured third-party authentication. It's used like in SQL Server. It's used with SharePoint servers. A lot of their servers, even though there's authentication already built into the operating system, that's an additional authentication. It uses symmetric key encryption to validate people, keeps the database containing private keys of clients and servers. So there's a public key and a private key. There's a authentication server, a key distribution center, and then a ticket granting service that just lets the next one in line use that. We use that in our database classes toward the end of the semester. User logs in. It encrypts the password to send it to the client. It clears it through Kerberos. My tongue wants to tie. Then there's a ticket for between the client and the software. Then there's a ticket between the client, the public key, and the private key. So the client requests it, getting it the net client name, the time, what their keys are, then sends it to the server, and then the client authenticates the server by a ticket and the session key. So we all did encryption when we were young, probably saying this is going to stand for this and this is going to stand for this. But there is a public key and a private key. that the person on the other end has to supply the private. Secure European system is similar. The user is authenticated, and I was going to look at something in the book when I was going over that part right there because I remember reading it when I was doing it. This section promoting remote connections begins on 342, and these are all kinds of remote authentications. I started to say sesame, but it isn't. These two are third party in addition to what's already built into the operating system or to the firewall itself. Uses the public key encryption just like the other one does, so that more sophisticated if you're working in a really secure environment. And then the private virtual networks, to a trusted one, a secure one, a hybrid one, 3 different types, and those begin on 346 in your book. And they, let me go. Encapsulation of incoming and outgoing, encryption, and authentication are those. The most common allows the user to turn the internet into a private network. In the transport layer, the IP packet is encrypted. The header information is not. Allows the user to establish a secure link with the host. End-to-end, two popular uses, end-to-end transports of encrypted data, process the access connection to over the internet by connecting to that virtual private network, and it gives us a picture of what that actually looks like. This is just any user going into the to the router that does that encryption, and it's showing you that then for the destination for the encrypted data. Once it gets there, it's decrypted. So encrypts it, changes it so that it's secure. And then when it gets there, it's decrypted so humans can read it. 2 tunnel servers to encrypt all packets, the tunnel mode, and that's at the very end. That looks like to me, it's just parts of that private virtual network. 2 tunnel servers to encrypt all the traffic. So you've got servers that are just set up for the encryption itself. The package is encrypted and added as a data portion from another packet. So it's like creating a container for that packet. Then an intercepted packet reveals nothing but the true destination. Microsoft's Internet Security is an example, and the ISS server is an example, showing you a picture of what it looks like. You can, it depends on the organization. You can do things like FTP, instead of Microsoft used to have a pretty big supply of resources out here on its FTP. I'm not sure if that's as secure as it used to be. It looks like my firewall doesn't want to go there. You used to could just go out onto the FTP site of Microsoft and download all kind of white papers and that kind of stuff. Looks like it's not going to go. It's just like my operating system a few minutes ago when I was going to try to look at, now watch, let's see if it does. I just wanted to be able to show you where you go to look at your IP addresses. And when I selected one, and chose properties, it just gave me a help screen. It didn't want me to go there. So security, chapter 6 is important. I know that there's a lot of information in Chapter 6, honestly, that I need to to look at more closely myself. I said I didn't consider myself a network person, but you really need to be one to be a cybersecurity person. I just had to fill in for a class this semester that normally is not mine. Anyway, I hope this makes sense. I hope it's not too long. Have a good rest of the day.